Today we're starting section 4.6. We're still graphing trig functions, and now we're going to move into cosecant. So you're going to notice that the process for cosecant is almost identical to the sine. It's just the actual last step, the graphing step, is a little different. So amplitude, starting point, period, the whole process is exactly the same. It's the actual creation of the graph that is different. So for our first example, we have y equals 2 cosecant of 2x. So I want you to recall that cosecant goes with sine. So maybe just make like a note to yourself that whatever's true for sine is also true for cosecant. Okay? So we're still going to find our amplitude, period, starting point, all of that. So my amp is 2, my starting point. I don't know why I wrote it like that. Our starting point is c over b. So notice I don't have a c value, so my c value is 0. My b value is 2. 0 divided by 2 is 0. Our period is 2 pi over b. So 2 pi over 2. So the period is pi. And then we find our period over 4. So our period was pi this time over 4. Can't do any reducing with that. So the next thing we find is our coordinates. So x1 is always our starting point, so our x1 is 0. And we're adding pi over 4 each time. So x2 is pi over 4. x3 is 2 pi over 4, which we know will reduce to be pi over 2. x4 will be 3 pi over 4. And our last coordinate of 5 is going to be 4 pi over 4, which is just pi. So again, same procedure. The actual graph, the creation of that, is what is different. So I'm going to switch the slides to the graph. Make sure you have everything jotted down. If you don't, pause the video. So we're going to make our axis, and our amplitude is 2. So we'll make this 1, make that 2, just so it's not so itty-bitty. And our period, we need to go from 0 to pi. So again, let's kind of spread it out. So 1, 2, 3, we'll make that be a quarter pi. 1, 2, 3, half pi, 3/4 pi, and a full pi. So again, you just want to make sure when you draw it makes sense and it's evenly spaced. That's really what I'm looking for the most. Okay, so now we get all the information on the graph. So this is a cosecant goes off the sine wave, so we're going to treat this as if it's a sine wave. Do not connect the dots, whatever you do if you're working ahead of me. So my x1 value is an intercept, x2 value is a max, intercept, min, and intercept. So we're not going to connect these dots with a solid line, we're going to connect it with a dashed line. So the reason we're connecting it with a dashed line is this is not a sine wave, it's a cosecant wave. However, we use the sine wave as like the skeleton to create our picture. So the new part here is that wherever your x-intercepts are, we draw asymptotes. So I'm going to have 3 asymptotes for this. So there's another one, and here's our third one. And the way we spell that is ASYMPTOT, asymptote. And it just means that the function will get very, very close to, but will never touch. Also, to kind of tie this together, if you look at your trig chart, you're going to notice that sometimes the trig functions are undefined. Well, this asymptote represents an undefined value. And now, once you have your asymptotes, what we do is we reflect our graph away from the x-axis. So notice this piece right here, you see an upside down U. This is going to reflect up. It's going to stay within those 2 asymptotes, and it's reflecting away from the x-axis. Similarly, you have a right side up U. Now you have an upside down U. So the domain for this is no longer going to be negative infinity to infinity. So we're going to now have exceptions. Okay, so it's negative infinity to infinity except multiples of half pi. So notice every half, so here's a half, there's an asymptote. So a half and a half is a whole, so there's one, that's their asymptote. Your next asymptote will happen at 1.5 pi. Okay, so that's how you do the domain. The range, notice again, now it's not going up and down between those type values. So before it was going up and down between -2 and 2. Now it's everywhere except that. So the range is negative infinity to -2, union with 2 to infinity. So that's how you do the cosecant wave. So one more example. We'll do y equals a negative cosecant of x over 2. So real quick, just to go over our values. My a value is -1. My b value is 1/2. And c is 0. So my amplitude is -1, so that kind of goes back to the idea that we go to a min rather than a max first. Our starting point is c over b, so 0 over 1/2 would still be 0. Our period, so 2 pi over b, so 2 pi over 1/2. So here we have to do the whole keep, change, flip, or multiply by the reciprocal, whatever way works for you. I keep the top of 2 pi, and I multiply by the reciprocal of 2 over 1. So the period is 4 pi. And when I find the period over 4, 4 pi divided by 4 is pi. So this will be a nice and easy one. So x1 is 0. x2 is pi. x3 is 2 pi. x4 is 3 pi. And lastly, we end at 4 pi. And again, adding pi each time. So we're going to go ahead and create the graph. We're going to pretend or treat this as if a sine wave first, and then we build off of that graph. So if you're working ahead, just make sure you do not connect the sine wave with the solid line. So on our graph, we're going to make, so our amplitude is a 1 and a -1. And again, just spreading it out so I have more room. So the period goes by pi's. So every other block I'm going to just make a pi. So this would be 1 pi, 2 pi. Actually, let's spread it out so you kind of get the effect. We'll make this be 1 pi. It's every 4 blocks. So that's 2 pi, 3 pi, and a 4 pi. So this way it looks nice and stretched out. So there's the 4 pi, and so on. So using a dotted line, we're going to create our sine wave. So still starting at an intercept, our x2 value is a min because the amplitude was negative. Intercept, max, and intercept. And we're going to use a dotted line to connect my sine wave. And now we draw our asymptotes at our intercept. So we have an asymptote at pi over 4, at 2 pi, and at 0. And then the last thing that we do, again, is we reflect our wave away from the x-axis. So this first piece is going to reflect downward, and this piece will reflect upward. So my domain is going to be all reals or negative infinity to infinity, except even multiples of 2 pi. And our range is going to be negative infinity to negative 1, 1 to infinity. Now going back to the domain, you could word it differently. You could say every other multiple of pi, just implying that it's going to be all your even ones. So that's all for today, and we'll pick up with this tomorrow.